Okay, and let's apply. Look back at your triad, right? Which model or strategies do you like best? You can think about that and, I don't know, see what you think. Okay. Mathematicians define trapezoids in two different ways. Trapezoids are quadrilaterals, right? Trapezoids are quadrilaterals with exactly one pair of parallel sides. One pair of parallel sides. Trapezoids are quadrilaterals with at least one pair of parallel sides. Okay, write exactly one pair or at least one pair to show which definition of trapezoid was used to make each Venn diagram below. So at least one pair and exactly one pair. So this one will be what? Which one do you think? This one will be at least one pair, because it means it could have more. And this is exactly one pair. It means it'll be different. One pair of parallel sides. So they want you to understand the difference between at least versus exactly. If it's at least, then it can fit around here because it's at least one pair. A parallelogram has two pairs of parallel sides, right? And this has two pairs of parallel sides, but this has some right angles in it, the rectangles, right? But here, if we say the trapezoid has exactly one pair of parallel sides, it can't be around here because these don't. These have more than one pair of parallel sides, and this has exactly one pair. So it has to be an oval separate from this one, okay? All right, let's look at this. Sort these shapes into Venn diagram based on the properties of having parallel sides and having perpendicular sides. Parallel sides and perpendicular. Do we know what perpendicular is? This is perpendicular, right? Okay. Sort these shapes. Let's think for a minute. Write category labels for two ovals. All right. Shapes with parallel sides and shapes with perpendicular sides. Let's do it. Shapes with parallel sides and shapes with perpendicular sides. What shapes would go into the one with parallel sides? A, E, and C. Do you see that? A, E, and C. Which ones would go into the oval shapes with perpendicular sides? This one has a perpendicular side, and this one has a perpendicular side, and this one has a perpendicular side. But they also have parallel sides. This one has a parallel side, and this one has a parallel side. So which one is the only one that has a perpendicular side but not a parallel side? D. Which ones have properties of both? So we'll have F and B. Boom, boom. So F and B, they both have perpendicular sides, right, which is sides like this, straight edges, and they both have parallel sides, right? Top and bottom, they're parallel to each other, sides are parallel to each other, okay? Number 9. Remember, if this is a little confusing, and it could be, just slow down your video and go back a little bit. Which definition in problem 7 lets you classify shape A in problem 8 as a trapezoid? Explain. All right. The definition of a trapezoid, remember the definition, has at least one pair of parallel sides. One possible explanation is that shape A is a parallelogram with 2 pairs of parallel sides. And I'll write that down for you. So this is the explanation for the definition that a trapezoid has at least one pair. One pair of parallel sides, right? That's the explanation for that one. And now we're going to do the other one, which is the at least one pair Venn diagram shows that a parallelogram are also trapezoids under that definition. And remember, we drew this in your book, so you should have that one that we labeled the at least one pair Venn diagram. It shows that parallelogram is a very long word to always write all the time. Also trapezoids under that definition. Okay, and that is number 9, and that is the end of this lesson. So let's go back to, I can classify two-dimensional shapes or figures. That's what we're trying to do. All right, guys, shoot me any questions that you have about it. Remember, 10 a.m. every day, mini math sessions. I would be glad to help you with your refined section or the fluency sheets. See ya. Bye.